Alright guys, we're going to talk about how to write our absolute value functions given the graph today. Alright, so our transformations are still here, but now we're going to be given the graph and we're working backwards to write our absolute value function, whereas prior to this we were given our equation and we were asked to graph. Okay, so here is my parent function, my parent graph, right? We have the absolute value of y equals x. This is the parent graph because it goes through the origin. Here's my vertex at 0, 0. It has not translated to the right any. It has not translated up or down any. The slope, the a, the coefficient, is 1 because we rise 1, run 1. Rise 1, run 1. Okay, so it says, if given the graph, identify the transformations of the graph from the parent function. So we have here parent function. Okay, now what changed to get this graph? Well, we can see here that my vertex is at negative 1, 3. So we know we have a vertical translation to the left 1. I'm sorry, a translation to the left 1 and a vertical translation up 3. Okay, so if I was to write this as an absolute value function, okay, I'm going to leave a for now. So we're going to say y equals a absolute value of x minus h. Now remember, this controls right or left. Sorry, this controls right or left. This controls up or down. Okay, so we know right now that we went up 3, so we're going to have a plus 3 at the end. And we know that we went left 1. Now remember, this is the opposite of h. So if we went left 1, we're going to be a plus 1 inside the absolute value. Now we need to look at the slope. This slope is still up 1 over 1, so my a is still 1. Now I'm not going to write it. So here is my absolute value function. Absolute value of x plus 1 plus 3. Okay, it says if the absolute value parent function was translated right 3 units and down 9 units, as well as stretched by a factor of 3, what would be its new function? Okay, so the absolute value parent function is y equals the absolute value of x. Now I'm going to stretch it by a factor of 3, so my new a value is going to be 3. We're going to translate it right 3 units, so that's inside the parentheses, or inside the absolute value sign. We're going to go down 9 units. So that's going to be outside. There's your absolute value. Alright, so let's look at 3 examples here. Number 1, here's my graph. We're asked to write the equation. So we need to find our vertex. Our vertex is at 3, negative 1. Alright, so again, we're going to write our absolute value. We went right 3, so it's going to be x minus 3. And then we went down 1, so minus 1. Now we need to check our slope. Okay, we went up 1, 2 over 1. Up 1, 2 over 1. So our slope, our a, is a positive 2. Positive 2. So there is your equation. Bada bing, bada boom. Number 2. Okay, we can see number 2 that this absolute value inequality is upside down. Oh my goodness. So we know right now that it has to be negative. Okay, again, I'm going to leave a blank for my a, absolute value of x. Let's find our vertex. Our vertex is at 0, positive 5. So we didn't have a translation to the right or to the left. So it's still going to be the absolute value of x. But now outside of my absolute value, I'm going to have a translation up 5 units, so plus 5. Now let's find our a value. So we need our slope. We went down down a half over 1. Okay, so my slope is a negative 1/2, right? We went down 1 over 2. So negative 1/2. Alright, and we call that a vertical compression. Right? So vertical stretch, greater than 1. Vertical compression, less than 1. Again, this negative outside is a reflection over the x-axis. Number 3, oh my goodness, it's upside down too. Y equals negative. I'm going to leave a blank for now, so the absolute value of x. Now let's find our vertex. Our vertex is at positive 2, negative 1. We know we had a horizontal translation 2 units to the right And again, it's opposite, so it's a positive 2. I may get a negative inside my absolute value sign. We went down 1, so minus 1 at the end. All right, and now we need to find our slope. So from here, we went down 1 over 1, down 1 over 1. Perfect. So it's just a negative absolute value of x minus 2 minus 1. Bingo, bango, bongo.